This is additional problem A-2, and you have a pile driver. So here's the pile driver. It's usually connected to some sort of crane mechanism that has a long cord to it. And what they do is they drop this onto, so it'll come down here, here it is again, and then it'll go onto a stake that's sitting in the ground. And so we can draw the ground here, and we're trying to drive this thing down into the ground. They gave us the mass of the pile driver. They said that the mass of the pile driver is 3,000 kilograms. They tell us that the distance that this thing falls, so here's the distance, is approximately 8 meters. So we're going to call that D1, call M1 the mass. They said that there is a force on this stake of a number here is 5 times 10 to the 6th newtons. So that's our second force. They want to know how far down into the ground, so they want to know D2, how far is the distance that it's driven. Because we have a force and a distance and another distance, we need the original force of this pile that we're dropping. So to find that original force, F1, we're going to take mass 1 times gravity. Our first mass is 3,000 kilograms. We know the value for acceleration due to gravity is 10 meters per second squared. And when you multiply the two, you get 30,000 newtons, and that's for F1. At this point, we can use the equation F1 D1 is equal to F2 D2. That's for work. So work in should equal work out. We've got 30,000 newtons on one side. Our distance we said was 8 meters. That's equal to the second force, which is 5 times 10 to the 6th newtons. And then we can solve for D2. When you do your math, you should end up on this problem with a distance of 0.048 meters, and that should be equal to your distance. And that is the end of problem A-2.